Now then, it's raining again. It's the middle of summer, so we shouldn't be surprised. And we're just waiting now for a spell of dry weather so that the hay can be cut. But this is an interesting little conundrum. What we have here are some quite big lithium ion batteries, quite chunky, and some chargers. Now there were 2 batteries and 2 chargers, which is sort of fairly interesting, and it enabled us to do some analysis with a lot. This came from Dave from the top end of the county. I was up there doing some forestry and he said, "Do you want these?" They're apparently, they run his diesel pump for pumping diesel into cans and various vehicles and stuff from his store. 24 volts. And I thought, okay, yeah. He said, I phoned the company up and told them that it was faulty, and they sent me some more. I thought, well, you can't say fairer than that, can you? But why were they faulty? It's a very good question. So I thought we'd investigate, and using the multimeter, etc. And Pat made a comment on the last video about volts and amps and watts. Show us how you're using the multimeter. I thought, yeah, okay. So I'll do a video about that fairly shortly, in line with a whole series that I'm hoping to do about the various uses of meters and the application of bits of Ohm's law. Just the bits that you would normally use. Don't want to get into sort of long convoluted technical stuff. Real basic down to earth rules of thumb, and this is what you do. Anyway, let's have a look at this these batteries and chargers. I have done some previous investigation. So unlike a lot of my videos where I'm making it up as I'm investigating and things change, and I've done a bit, and what I found is it's typical of modern equipment. And so, you know, let's crack on and have a look. Okay, they're quite chunky, these these batteries, and it says 25.2 volts, 3 amp hour, 75.6 watt hours. Okay, I think we'll just have a look at that, do you a shot of that label before we go any further. There we are. So the first thing I did was, there was 2 of these battery chargers. Okay, one had got a British plug on it, the other one had got a Euro plug on it, and of course the one that had the Euro plug had not been used. Yeah, so I chopped it off and exposed the leads. So later on we'll see how I use that one. Okay, so let's just plug this charger in. Now there's all sorts of, there's a label here that tells you what things, what is supposed to be happening. So we plug the battery in, and let's zoom down on that. Now we have the standard problem. Okay, green and red. Is that red or is it green? I think that's red, and I think that's green. Right, so red, if it's flashing, I think it says there's something wrong, and if it's not, then it's on. That's what I'm assuming. And the one on this side, it's got all these indications here. Well, nothing's going on. nothing at all. Okay, so there's a bit of a conundrum there, what's going on. So, okay, here's the battery. What is going on? Let's put a something there and a something there, and put the meter on volts, DC volts, and go across these, and we have 3.4. That's not very good, is it? So the question is, on this charger, why didn't we get this light saying something like it's wrong, or there's a fault, or something like that? Maybe it's because this battery has been over discharged. How's that happened? Maybe because the battery management board is about as much use as a poke in the eye with a pointed stick. Anyway, so what I did then was I took one of the packs out. This is out of the other battery, okay, and measured across the negative there and the positive there, okay, and it showed a couple of volts. I thought, okay, here we go. Yep. So again, now some of you remember that I have a way of charging up batteries from the big 48 volt battery pack through a light bulb, like a 60 watt 240 volt light bulb will let a small amount of current through. So what I did was I put this battery on those battery terminals, and I charged it up very slowly through what I call the resistance charger. And we just turn the meter up to the next setting. We've got 24.5 volts. Okay, so that took a while because it was very low and you don't want to charge it up rapidly. Okay, so there we go. 24.5 volts. We have the charger, and we'll just try and wrong way round. Okay, we'll put a piece of wood there like that. Okay, so what's this doing now? It's still showing whatever colour that is, and this one here that I assume is green, but here we got the conundrum of focus. Yeah, that is lit. Okay, so something's happening there now. So it's on fully, and it says that should mean charging. Now, it was 24.5, wasn't it? Okay, so let's go across the battery terminals. (25.1). I can only assume that either the charger is faulty or the battery management is faulty, because that is charging 25.1, so something's happening. Okay. And the reason I know that is because I took the batteries out of the case. Okay. So now that looks like the positive and this looks like the negative. Why is it only showing 15.2 when the battery itself shows more? Have we got any current there? So is the battery management system dodgy? Okay. I can't put it across the battery terminals because it will just pop this bulb, because this is only a 12-volt bulb. There again, like that Dyson battery vacuum, we had power in the cells but nothing in the output. Well, we got 15 volts on the output, and whoa, hello, what happened there? Did I just pop that bulb? I think I did. Okay, put the bulb round to continuity. Yeah. I just popped that bulb. Okay. Pop it back to DC volts. Ah! Now that's weirder than the weird thing, isn't it? Hey? Because you saw it 15 point odd volts and no current, and then suddenly it's as if it's switched on. Very odd. One of the commenters, and I'm afraid I can't remember who it was, it could be Equilux, talked about waving a magnet near the BMS to reset it. Okay, so I'm going to do that, but it looks like it's reset itself. Let's just try that again. You saw it here first. Yeah. We seem now to have, I wonder if we've got a duff connection somewhere. Right, let's stick this back in there. Put a piece of wood under there. $25. I'm going to leave that on for a minute, and I'm going to go and find a magnet. There we go. Some magnets out of a they're pole pieces out of a DC permanent magnet motor. Okay. I don't expect that to make any change because it's already just... Ah! Look at that. It's gone down to 15.3 again. And no current, I bet. Very interesting. So the green light is on, which I think is showing charging, and it's 25.1. I'll just put those magnets together before they snap on my fingers. What are we making of this? Do you think wafting the magnet over that BMS has damaged it? I can't think that that would be the case. Strange. What do we do now? First of all, we find another indicator bulb, don't we? So give us a second. Okay, I found another bulb. Let's move this meter round to continuity and check that the bulb is fine. And it is. Right, what's the resistance of this bulb? 0.8 of an ohm. Okay. Right. So if we put a resistor of an equal value in series with this, then it will run on 24 volts without blowing up. But 0.8 is quite a low value. What I've got here is a variable resistor. It's a power variable resistor, potentiometer, or whatever you want to call it. So let's pop that in there. Okay, and I'll turn this potentiometer right up as far as we can go. Okay, so the resistance across that potentiometer is something that I can't measure for some reason. Let's try that again. Goes between there and there. 5. So there you go. I'm not quite sure what's going on there. We could do with another crocodile clip. No, we don't need that. Right, so I've turned that potentiometer right up and the bulb's lit. Okay, across the battery itself. And it's been charging for a short while. Put that back to DC volts on the 200 scale because we're above 20 volts. And it shows 25.5. Well, there you go. So that's working. Right. Yeah. Okay. So the clue here is that I took the battery out of its case, so you could actually measure the difference between the battery volts on the battery terminals and those on the battery management and the connection. Very strange indeed. Yeah, so let's have the other battery apart and just see if there's a duff cell or it has exactly the same symptoms. So that one can go back in and it should work. And this is pairs of cells, so these cells will be 1.5 amp hours and there are 2 in parallel, 2 in parallel, 2 exactly. Yeah, so it's 6 lots, 1, 2, 3, 4, 5, 6, 7 lots of parallel cells, if you get what I mean, because it's a 3 amp hour pack, so they've series parallel the batteries. There we go. Put that over there and the 4 screws. Oh, and it pops out quite easily. I can't remember, you see, because it's a while since I've done this. So now these have got a different, these are Samsung. I'm going to just show you that so that those people who are really into batteries will investigate. Focus. There we go. Different set of batteries in this one. I'm assuming Samsung are a good maker battery. And you can see there's this what they call it, duct tape here. It almost looks like it's been put together by hand. So we've exposed the two connections there. We're on DC volts, and we've got a positive there and a negative there. Okay. So it shows virtually no volts there. Ah! Bad connection. We've got 26 volts there. Okay. And we had no volts across this one. Or 3 volts or 0.3 or something. Okay, so the batteries are charged, but this BMS is not showing any voltage output. So I think it's time to do the magnet trick. Okay. Nope. Let's go back to the start. There's a positive and there's a negative. Put it that way up. Very strange. Okay, let's plug it in the charger. Bit of wood. .26 volts. Interesting that, where are we? Whereas the other battery had 2 terminals that side, this one's only got 1. So it had 2 of these clippy things there and there. Very strange. Ah, right, now we've got a green light that's blipping, and that says 100%. At least I assume that's what it means. You tell me if I'm wrong. So that light there, this one here, is just flashing. So I'm assuming that says it's 100% charged. This whole thing of red green LEDs is a total 100% pain in the neck for colourblind people. It's discrimination, that's what it is. So I think we seem to have got the other battery to work, whatever reason, but this one seems like it has a faulty battery management system. Let's just see if we've got any power there. We have nil power. Right, we've got power there on that connection, okay, but not power there. So it's not getting through the battery management. Whereas the other one here, which as you notice has got 2 terminals there, is working. So we got 1 out of 2 that's working. So I'm just going to put this back together. That spring catches there. This is pushed down. That should go back together with a bit of luck. And of course, it's in my opinion that you shouldn't let the battery management, you shouldn't manage your batteries by discharging them all the way and letting the battery management switch off and then charge them back up again. And you shouldn't, on the other side of that, just use it for 5 minutes and then charge it up again. But it's a matter of going, I've used this for half an hour, I'm going to charge it back up again. Yeah, and that way the battery management system doesn't have to work so hard, and you're not cycling the batteries deeply. I don't think they have a memory effect like the really early batteries used to. So reducing the number of cycles by charging them more frequently and not demanding of the battery management system that it works for you will make your batteries last a lot longer. So there you go. One of those BMS, I think, the low voltage shutdown is faulty and allowed the battery to be over discharged, and I put some little notes up on during the video as to how I was thinking about things whilst I was editing the video. So there you go. The other one, I think it will allow charging but not allow any power out, so that is just a source of half decent cells for something else. Hopefully you've enjoyed this and, like me, learnt something about batteries, lithium batteries, by trial and error and experimentation. I have not got a clue what the next video is about, but I'll catch up with you soon and then you'll find out. Cheers for now.